In a week marked by a confluence of significant developments, NASA continues to demonstrate its multifaceted commitment to space exploration, workforce development, and strategic leadership. From critical advancements in its ambitious lunar missions to cultivating future talent and facilitating career transitions, the agency is navigating a dynamic period that underscores its enduring role at the forefront of scientific and technological innovation. At the helm, the agency is seeing a period of transition as Duffy assumes the role of acting NASA administrator. This leadership development comes at a pivotal time for the space agency, which is deeply immersed in its ambitious Artemis program aiming to return humanity to the Moon. The appointment suggests a focus on continuity and steady progress as the agency pushes forward with its long-term objectives. Indeed, tangible progress on these grand missions remains a central theme. NASA is actively preparing a key piece of the Artemis IV moon rocket, a crucial step forward in its systematic approach to lunar exploration. This development signifies the meticulous and demanding work involved in readying hardware for deep space missions, reinforcing the agency's commitment to establishing a sustained human presence on and around the Moon. The Artemis IV mission, following its predecessors, is designed to expand the infrastructure and capabilities for future lunar activities, laying the groundwork for eventual human missions to Mars. Beyond the hardware and high-level leadership, NASA is also deeply invested in the human capital that drives these endeavors. A notable initiative at the Johnson Space Center exemplifies this, as a new program is building a vital bridge from military to civilian careers for its team members. This strategic effort not only taps into the invaluable skills, discipline, and experience of military veterans, but also provides a structured pathway for them to contribute to the nation's space enterprise. Such programs are essential for diversifying NASA's workforce and ensuring a continuous influx of highly capable individuals, recognizing the unique contributions veterans can make to complex technical and operational environments. Furthermore, NASA's engagement with academic institutions continues to foster the next generation of innovators. Old Dominion University recently celebrated a significant achievement, with its team securing second place and a $5,000 prize in a national NASA competition. This success highlights the agency's proactive approach to inspiring and investing in STEM education, encouraging students to tackle real-world challenges in aerospace. These competitions serve as vital proving grounds for emerging talent, providing practical experience and a direct link to the space industry, ensuring a robust pipeline of skilled engineers and scientists for years to come. Collectively, these announcements paint a comprehensive picture of an agency operating on multiple fronts. From the strategic leadership guiding its direction and the painstaking preparation of next-generation spaceflight hardware to the crucial efforts in workforce development and educational outreach, NASA's current activities are deeply interconnected. They underscore a unified vision to push the boundaries of human knowledge and exploration, supported by a diverse, skilled, and continuously evolving workforce. As the Artemis program progresses and new talent is cultivated, the coming years promise further breakthroughs that will shape the future of space exploration. The vast expanse of space continues to be a frontier of both remarkable triumphs and persistent challenges, as evidenced by a flurry of recent developments in human spaceflight. From the delicate choreography of crew rotations to the ambitious strides of private enterprise and the critical scientific efforts to ensure astronaut well-being, the narrative of our journey beyond Earth remains as dynamic and complex as ever. Just this week, the International Space Station ISS saw the successful return of a multinational crew, including astronauts from India, Poland, and Hungary, alongside a seasoned NASA veteran. Their safe descent marked another milestone in international collaboration, underscoring the global nature of space exploration and the routine yet always awe-inspiring process of bringing human explorers back to Earth. Even as one crew returns, the orbital outpost prepares for its next set of occupants. SpaceX is reportedly readying another private launch poised to send 4 more astronauts to the ISS, further solidifying the pivotal role of commercial space companies in maintaining and expanding human presence in low Earth orbit. This upcoming mission highlights the accelerating pace of private sector involvement, which has become indispensable for NASA's operational rhythm and future ambitions. However, the path to space is rarely without its hurdles, and one major player is currently navigating a significant setback. Boeing's Starliner program, a key component of NASA's Commercial Crew Program, has unfortunately encountered further delays. Reports from Space.com indicate that the troubled spacecraft will not fly again until 2026, and crucially, its next mission will proceed without astronauts aboard. This decision effectively places Starliner in the doghouse, as one headline succinctly put it, delaying its operational readiness for crewed flights even further. The repeated technical issues and protracted certification process for Starliner have cast a shadow over Boeing's commercial space endeavors, intensifying reliance on SpaceX's Dragon capsules for astronaut transport and raising questions about the diversification and resilience of America's human spaceflight capabilities. The uncrewed nature of the next flight suggests a deep-seated need for more rigorous testing and validation before human lives are entrusted to the vehicle, a sobering reminder of the inherent risks and exacting standards of space travel. Amidst these launch schedules and program delays, NASA continues its vital work on the fundamental challenges of long-duration spaceflight, maintaining astronaut health. The agency is intensifying its muscle and exercise studies to maintain crew health in space, as detailed in a recent NASA.gov publication. Life in microgravity takes a severe toll on the human body, leading to bone density loss, muscle atrophy, and cardiovascular deconditioning. These studies are not merely academic exercises, they are crucial for the feasibility of future deep space missions such as those to the Moon and Mars, where astronauts will spend much longer periods away from Earth's gravity. Understanding and mitigating these physiological impacts through advanced exercise regimes, nutritional strategies, and potential pharmaceutical interventions is paramount to ensuring that astronauts arrive at their destinations healthy and capable of performing complex tasks. The success of these health initiatives will directly influence the duration and scope of humanity's reach into the solar system, making them as critical as any rocket launch or spacecraft development. In essence, the current landscape of human spaceflight is a vibrant tapestry woven from threads of innovation, collaboration, and persistent scientific inquiry. While the commercial sector, led by companies like SpaceX, is rapidly expanding access to orbit, and international partnerships continue to thrive, the challenges faced by programs like Boeing's Starliner serve as stark reminders of the immense complexity and unforgiving nature of space engineering. Simultaneously, NASA's unwavering focus on astronaut health underscores the foundational requirements for truly pushing the boundaries of human exploration. As we look towards 2026 and beyond, the interplay between technological advancement, commercial competition, and the profound physiological demands of space will continue to define the next exciting chapters of humanity's journey among the stars. The ambitious push to expand humanity's presence in space continues to navigate a complex landscape of groundbreaking achievements and persistent challenges, as evidenced by recent developments across the aerospace sector. While astronauts aboard the International Space Station (ISS) diligently pursue scientific research and maintain their well-being in orbit, a significant setback has emerged for one of NASA's key commercial partners, Boeing, with its Starliner spacecraft facing further delays. In a development that underscores the inherent difficulties of spaceflight, Boeing's Starliner crew capsule will not undertake its next flight until 2026, and critically, this mission will be uncrewed. This announcement, made on Thursday, July 17, 2025, marks a considerable step back for the program, which only recently completed its much-anticipated crew flight test (CFT) to the ISS. The decision to send the capsule up empty next time, effectively putting it in the doghouse for future crewed missions, indicates that significant issues were uncovered during the CFT that necessitate extensive re-evaluation and modifications. This protracted timeline not only impacts Boeing's commercial aspirations but also places additional strain on NASA's Commercial Crew Program, which relies on both Starliner and SpaceX's Crew Dragon to ferry astronauts to and from the orbiting laboratory. The implications for the program's long-term strategy and the diversification of access to space will undoubtedly be a focal point of discussion within the industry in the coming months. Despite these programmatic hurdles, the human element of space exploration presses forward, with astronauts continuing their vital work on the International Space Station. Maintaining crew health in the harsh microgravity environment remains a top priority for space agencies worldwide. NASA, for instance, is deeply engaged in comprehensive muscle and exercise studies, recognizing that prolonged exposure to weightlessness leads to muscle atrophy and bone density loss. These studies are crucial not only for the current residents of the ISS but also for planning future long-duration missions to the Moon and Mars, where astronauts will spend months if not years. Far from Earth's protective embrace. Understanding and mitigating these physiological effects is paramount to ensuring the health and operational effectiveness of future deep space explorers. Amidst the rigorous scientific pursuits, life aboard the orbital outpost also includes surprisingly mundane yet essential routines. On Wednesday, July 16, 2025, reports from InsideNova.com highlighted the simple act of astronauts getting haircuts at the ISS barbershop. Such details, while seemingly trivial, underscore the importance of maintaining a sense of normalcy and personal well-being for crews living in extreme isolation for extended periods. These small acts contribute to crew morale and mental health, which are just as vital as physical fitness for successful missions. In related news, the Axiom 4 crew, including Shubhanshu Shukla, is anticipated to return to Earth on July 14, 2025, according to NASA. Marking the successful conclusion of another private astronaut mission that further diversifies human presence in low Earth orbit. The contrasting narratives of the Starliner's ongoing challenges and the continuous, albeit demanding, daily life and scientific progress on the ISS paint a clear picture of the current state of space exploration. While the development of new reliable spacecraft faces formidable engineering and safety hurdles, the commitment to understanding and adapting to the space environment through dedicated research and human resilience remains unwavering. The Starliner delay serves as a stark reminder that even with decades of experience, spaceflight remains an incredibly complex and unforgiving endeavor, demanding meticulous attention to detail and exhaustive testing. Yet the persistent efforts in astronaut health and the regular rotation of crews demonstrate humanity's enduring drive to push the boundaries of exploration. As the space industry looks towards 2026 and beyond, the focus will undoubtedly remain on balancing innovation with safety, ensuring that the next giant leaps are taken with the utmost care and precision, building a sustainable future for human presence beyond Earth. In an era defined by rapid technological advancement and an ever-deepening understanding of the cosmos, NASA continues to stand at the forefront of exploration and innovation. Recent announcements from the agency underscore its multifaceted approach, tackling challenges from safeguarding human health in extreme environments to unraveling the fundamental mysteries of life beyond Earth, all while laying the groundwork for a robust future space economy. A paramount concern for humanity's ambitious ventures into deep space remains the well-being of astronauts. With an eye towards extended missions, including potential journeys to Mars, NASA is intensifying its research into the physiological impacts of microgravity. New studies focusing on muscle and exercise are crucial to developing effective countermeasures against the severe muscle atrophy and bone density loss experienced by astronauts in orbit. This vital research, announced on July 16, 2025, aims to refine exercise protocols and nutritional strategies, ensuring that crews can maintain peak physical condition throughout prolonged periods away from Earth's gravity, a critical factor for mission success and astronaut safety. Simultaneously, protecting our planet from the dynamic forces of space weather is a key priority. The upcoming Tracers Tandem Reconnection and Cusp Electrodynamics Reconnaissance Satellites mission, highlighted on July 17, 2025, is poised to provide unprecedented insights into the mechanisms behind phenomena like geomagnetic storms. These events, driven by interactions between the solar wind and Earth's magnetic field, can disrupt power grids, communications systems, and satellite operations, posing significant threats to modern infrastructure. By tracking the precise dynamics of these interactions, Tracers promises to enhance our ability to predict and mitigate the impacts of space weather, safeguarding critical technologies that underpin daily life. Beyond Earth's protective magnetic bubble, the tantalizing prospect of life elsewhere in the universe continues to drive profound scientific inquiry. Intriguing new research from NASA reported on July 17, 2025 suggests a plausible pathway toward the formation of protocells, the precursors to living cells, on Saturn's moon Titan. This groundbreaking work explores how complex organic molecules abundant in Titan's methane-rich environment could spontaneously organize into membrane-like structures, a critical step in abiogenesis. Such findings not only deepen our understanding of the origins of life on Earth but also significantly broaden the scope of environments where life might potentially emerge, making Titan an even more compelling target for future astrobiological missions. Underpinning these ambitious scientific endeavors is a strategic focus on cultivating a sustainable and accessible space ecosystem. This vision for a burgeoning space economy received notable recognition, with a NASA Langley engineer honored for their significant contributions to this burgeoning sector, as reported on July 17, 2025. Such acknowledgments highlight the agency's commitment not only to groundbreaking science and exploration but also to fostering innovation, developing new technologies, and inspiring the next generation of space entrepreneurs and researchers. This holistic approach is essential for transitioning from government-led missions to a more diversified space enterprise, attracting private investment and expanding human presence in space. Collectively, these recent developments paint a vivid picture of NASA's relentless pursuit of knowledge and progress. From ensuring the health of our brave explorers and protecting our planet from cosmic hazards, to exploring the fundamental building blocks of life beyond Earth and nurturing the economic infrastructure that will support future space endeavors, the agency's work is as diverse as it is profound. As humanity ventures further into the cosmos, these foundational studies and missions will undoubtedly pave the way for discoveries that will reshape our understanding of the universe and our place within it. Mars, the enigmatic red planet, continues to captivate humanity, serving as both a frontier for cutting-edge scientific exploration and a canvas for our collective imagination. Recent developments across various fronts underscore this duality, highlighting the relentless pursuit of knowledge by robotic explorers while simultaneously fanning the flames of public fascination, even as physical pieces of the alien world find their way to Earth. In a significant stride for interplanetary robotics, NASA's Perseverance rover recently achieved a new milestone, completing its longest single drive on the Martian surface. This impressive feat, reported on Thursday, July 17, 2025 by Orbital Today, demonstrates the rover's robust capabilities and its critical role in the ongoing Mars sample return campaign. The rover, which landed in Jezero crater in February 2021, is systematically exploring a region believed to have once harbored an ancient lake and river delta, collecting rock and regolith samples for eventual return to Earth. The continuous operational efficiency of such missions is evident in regular dispatches like the one from NASA Science on Wednesday, July 16, 2025, detailing data acquisitions such as Sol 4596, right navigation camera cylindrical projection, which signifies the rover's constant surveying and mapping of its surroundings, crucial for planning these ambitious traverses. These long drives are not merely about distance. They are meticulously planned maneuvers designed to access diverse geological features, enhancing the probability of discovering biosignatures or understanding Mars' past habitability. The impact of such achievements is profound, pushing the boundaries of autonomous navigation and robotic endurance in extreme environments, directly paving the way for future human missions. Yet even as scientific instruments meticulously map the Martian terrain, the planet's alien landscapes occasionally spark more speculative interpretations. WION on Thursday, July 17, 2025 highlighted the public's fascination with unexplained doorways and mysterious faces purportedly found by NASA on Mars. These intriguing formations, often shared widely on social media, are typically the result of pareidolia, the psychological phenomenon of perceiving familiar patterns in random stimuli, combined with the unique geological processes that shape Mars' surface. While scientists consistently explain these features as natural rock formations, the enduring allure of the unknown ensures they continue to capture public attention. serving as a reminder of the human tendency to seek meaning in the unfamiliar and the powerful role of visual data in shaping our perception of other worlds. This interplay between scientific discovery and public interpretation underscores the importance of clear communication in space exploration, balancing rigorous data with broad accessibility. Beyond the images beamed back from orbiters and rovers, tangible pieces of Mars also make their way to Earth, offering a direct, albeit rare, window into the planet's composition. In a striking demonstration of their value, the largest known chunk of Mars discovered on Earth recently sold at auction for a staggering $5.3 million, as reported by Fox Weather on Wednesday, July 16, 2025. These Martian meteorites are fragments of the red planet ejected into space by powerful asteroid impacts, eventually finding their way to Earth. Their rarity and scientific significance command exceptionally high prices. Unlike samples collected by rovers, which are carefully chosen and returned through complex missions, meteorites offer a random cross-section of Martian geology, providing invaluable data on the planet's volcanic history, atmospheric composition, and potential for past water. The sale of such a significant piece not only highlights the commercial value of extraterrestrial material but also fuels scientific research, as fragments often find their way into research institutions for detailed analysis, offering complementary insights to those gathered by robotic missions. Cumulatively, these recent narratives paint a vibrant picture of our ongoing relationship with Mars. From the methodical, technologically advanced exploration by rovers like Perseverance pushing the frontiers of our scientific understanding, to the intriguing, sometimes misconstrued visual anomalies that fuel public imagination and the rare, precious fragments that offer direct planetary insights, Mars remains a focal point of human curiosity and ambition. As technology advances and more missions are planned, the coming years promise even deeper revelations about the red planet's past, present, and potential future, bringing us ever closer to answering fundamental questions about life beyond Earth and humanity's place in the cosmos. In a week brimming with significant developments across the spectrum of space exploration, humanity's enduring quest to reach beyond Earth's confines has taken center stage, from the meticulous preparations for future lunar landings to profound discoveries hinting at life's origins on distant moons. These concurrent advancements underscore a multifaceted approach to space, blending ambitious human missions with the relentless pursuit of scientific understanding. At the forefront of current endeavors, NASA is making tangible strides towards its Artemis program, which aims to return humans to the Moon and establish a sustained presence. On Thursday, July 17, 2025, the agency conducted critical tests of scientific instruments within an Arizona crater, a site chosen for its geological similarities to the lunar surface. This rigorous simulation is a vital step in validating the equipment and procedures that future astronauts will employ during moon landing attempts, ensuring both the safety of the crews and the efficacy of their scientific investigations. The chosen environment allows engineers and scientists to refine operational protocols and instrument performance under conditions that closely mimic the harsh lunar landscape, minimizing unforeseen challenges once the missions are underway. Complementing these field tests, the physical infrastructure for future lunar journeys is also rapidly taking shape. On the same day, July 17, 2025, Space.com reported on the preparation of a key component for NASA's Artemis IV moon rocket. This ongoing assembly and testing of flight hardware signals steady progress toward the program's long-term objectives, which extend beyond simply returning to the Moon to include establishing a robust lunar outpost and eventually paving the way for human missions to Mars. Each piece of the colossal rocket represents years of engineering prowess and serves as a testament to the dedication required for such ambitious undertakings. These forward-looking efforts resonate deeply with the rich history of space exploration. Just a day prior, on Wednesday, July 16, 2025, ShareAmerica.gov offered a poignant reflection on the half-century mark since a pivotal figure, a pilot whose guidance was instrumental, helped usher humanity to the Moon during the Apollo era. This historical perspective reminds us of the foundational achievements that inspire and inform today's ambitious programs like Artemis, highlighting the continuous thread of innovation and courage that defines our journey into space. It serves as a powerful reminder that while technology evolves, the fundamental human drive to explore and understand remains constant. Beyond the immediate goal of human lunar return, the broader scientific frontier continues to yield astonishing insights. Mashable reported on Thursday, July 17, 2025, that the methane lakes on Saturn's enigmatic moon Titan could potentially harbor an early step in the creation of life. This revelation, stemming from ongoing astrophysical research, expands the scope of astrobiological inquiry beyond traditional water-based life, suggesting that exotic hydrocarbon-rich environments might also foster the complex chemical processes necessary for biological emergence. Such discoveries broaden our understanding of life's potential diversity across the cosmos and fuel the ongoing search for extraterrestrial biology. Collectively, these diverse news items paint a vivid picture of a dynamic and rapidly evolving space landscape. From the meticulous terrestrial rehearsals for lunar touchdowns and the steady assembly of next-generation rockets to the enduring legacy of past lunar triumphs and the groundbreaking astrobiological revelations from the outer solar system, humanity's engagement with space is multifaceted and profound. As the Artemis program continues its methodical march towards a sustained human presence on the moon, and as robotic probes continue to unlock the secrets of distant worlds, the coming years promise an unprecedented era of exploration and discovery, continually pushing the boundaries of what we know and what we can achieve beyond Earth.